Thank you.
You're welcome. Yeah, sometimes too many things happen. Okay, do you understand? Basically, DC that the basic for anyone want to learn electronics, but not a major. The major for this semester will be electronics. Okay, but you must know basically how the DC is working, and already showed you that one just quickly. Okay, go through it. You can say DC, that's a direct current, AC, alternating current. And we already going through that thing. And every time what I want, when you're looking into the sideway, you're able to recognize what is V peak, what is V peak to peak, what is the period, what is the frequency, okay? And the formula to converting from the period to the frequency or frequency to the period, okay? And also any definition, try to reading over and over. For example, what is a cycle? That is one complete occurrence of a repeating wave, such as one positive and one negative alternation of a sine wave. And what is the frequency or what is the period? That's what you need to go. Okay? And that basically just the basic thing on the math, like 10 power of 6, power of 5, 4, 3, 2, 1, 0, or minus 6, minus 5. We already did it. Okay? And also that the minimum requirement for technician. How to do a calculation, you adding or subtraction with a multiply 10 power of 3, okay? Or 6, okay? Or minus 3, minus 6, whatever. And already teaching you how to divide it, how to multiply it, okay, with the power, okay? That's what we already done last time. And also make sure you understand when we're talking about tera, then you have to know what is the 10 to the what power, okay? That will be 10 power of 12, giga 10 power of 9, and so on. That is the requirement, okay? If you could remember, you can open the table for a while, you can get a log, okay? And also, we're already talking about DC, okay? DC means direct current. So if you're looking in your car battery, this is your car battery. Connect into the headlight, okay? So when you turn it on, the light, then the current will be flowing from positive, okay, to the negative, okay? And that will be turned on the light. Now, how come we get that current? The reason is you get a current, the thing is you get an electron moving from a negative to the positive, okay? Electron current. And they're telling you how we get the current. But we'll be using the conventional current. That means current all the time will be flowing from positive to the negative. Okay, so if you're looking into this one, you understand you get a current flow and turn on the light. If you touch into the light here, you will be feel hot. That will be telling you electrical converting into the heat. Okay. Now, my question is, if the broken here, that means when you turn on, the light not on. How? How come they not on? I think that you have to answer me, okay? So I need the feedback so I can see how many students able to understand. When you turn it on the light not on. Why? How come?
Light might be broken.
The switch is off.
That means inside that light here, you get a resistor. Okay? You get a resistor inside. So that is broken. Okay? So that's why the light not on.
Mr. Pham, they call that a filament, right?
Yeah,
So that filament, when it's broken, it's like an open circuit and you get no flow.
right. But the thing is, we're using the resistor here to make sure they normally go with the resistor connect to the circuitry. Okay, so when the line not turn on, so my question is, what the current flow here?
Zero. It's not flowing.
Zero, correct?
Zero.
Zero. The thing is, when you get an open here, that means that we call an open circuit. The current cannot flowing through the open circuitry. Okay? And another question. If your battery is 12 volt, right here is 12 volt. When you open, the light not on. When you measure the voltage here, what voltage you think?
Still 12 volts.
The source.
Exactly. Still the same voltage on your battery. Okay? And if you turn on your light on, then the voltage on the other side must be less than 12 volt. Okay? So that is a very, very basic for the DC circuit. And also, we already telling you, resistor, okay? This is a symbol, and this is a resistor look like in the schematic, that look like symbol. And the letter R, unit will be in ohm, and you understand, they can be ohm, kilo ohm, mega ohm. They don't have a milliohm, okay? And this just telling you more information if you need to look into that, okay? And also this display different type of the resistor, okay? Different size, okay? Bigger size can handle more power, okay? Small size, less power. If you put more current into the small size, you cook it, they burn it out. Okay, different type of resistor, and another one here for your guys information. Okay, and also this is the way how to identify the value of the resistor using the color code. In a resistor, they get a general purpose and a precision. One will be 1, 2, 3, 4, 4 bands. And another one will be 1, 2, 3, 4, 5. Okay, 5 bands will be just more accurate than 4 bands. The calculation will be the same thing. And also telling you, if you buy one resistor for 4 bands, you pay 5 cents. If you buy a resistor for precision, you pay for 25 cents. Got much higher. Okay, and this is the table telling you for first band what the will be a first digit, second digit, and the third band will be multiplied by what number? For example, multiply by 10 power of 0 means 1. 10 power of 1 means multiply by 10. 2 by 100 and so on. Okay, and the last 4 band for general purpose, the tolerance will be plus or minus 10%, 5%, okay, or 20% if they don't have any color. That will be applied same thing for a precision. That we already get through that. That will be already get through that. Okay, conductance, that's just the opposite to the resistance. And now we're talking about Ohm's law. Okay, and the first thing is if you get the voltage supply E and you get the resistor R and you get the current I flowing. So relation between E, I, and R, that's what we call Ohm's law, E equal I times R. Or you can calculate I equal E divided to R. And also R equal E divided to I. Okay? And in this formula, E must be in volt, I must be in ampere, R must be in ohm. That's the basic. Okay. And also, they given you the formula how to calculate the power. Okay. You get the total 3 formula to calculate the power. You can using P equal V times I. Okay. Or you can use using the formula P equal I squared times R. And the last one will be V squared over R. However, either formula, they will be working the same thing. Only thing is, in this formula, unit of V must be volt, I must be ampere, and P will be in watt. Okay? So if you get milliamp or millivolt or whatever, you have to convert it to volt or to ampere. Okay, then we get the next one. Okay, a series circuitry we already get through last time here. Okay, I just quickly go back into here quickly, otherwise we run out of time. You get the voltage E here. Okay, and we get a R1, R2, R3. So in this circuitry, we go a series circuitry. You get only 2 circuits. One will be series, one will be parallel. Now we're talking about series. How do we know this is a series circuit? Based on the current. You see the current here, go to R1, then go to R2, then go to R3. They're telling you one thing. In the series, all of the resistor get the same current. Or we can say in the series circuitry, okay, you get only one path for the current flow. That is the way how to recognize the in series. Okay, now if they in series, then they need to calculate the total resistance in the circuitry, then add them up. That's what everything I already showed you in the handout here. If you want to calculate the voltage drop across R1, then they already telling you right here, okay? R2, R3, same thing. If you want to calculate the power, I square times R1, or I square times R2, or I square times R3, okay? And that will be the same thing. Now, quickly go to parallel. Voltage is the same across each branch of the circuit. Total current equal the sum of individual branch current. The equivalent resistance are equivalent. Is less than the smallest branch resistance. Total power is equal to the sum of the total power dissipated by each resistance. Now, if you're looking on this circuitry here, and we say this is a parallel circuitry, region A, the voltage across R1, R2, R3, the same with the power E. Okay, that means all resistors in parallel get the same voltage. However, if you can see the current coming out here R total, when they get to R1, you get I1 going here, I2 going here, I3 going this way. Okay, so this is what we call a branch current. Okay, so I1 plus I2 plus I3 plus IN equal the total I. Okay, they already see telling you everything here. Okay, and if you want to calculate the total resistance of the parallel, you can get this formula. R total equal 1 over R1 plus 1 over R2 plus 1 over Rn, no matter what, how many resistors in parallel you get. However, if you get only two resistors in parallel, then you can using this formula for short. R total equal R1 times R2 divide R1 plus R2. Okay, and now if you get this parallel here, you're looking into the circuitry, we want to know what is the total resistance. On three resistor parallel, you have to using the formula 1 over. Okay, 1 divide to R1 plus 1 divide to R2, or 1 divide to R3, so on. Okay, and I already given you the example, the answer. If you try to do it, you get the same answer, means you're doing the right one. Okay, and also this will be calculate the total here. However, first thing, you can combine R1, R2 in parallel to get R12. Then combine R3, R4 parallel to R3, 4. Then they in series, you add them up. Okay. And then on this example here, you get only one R1, R2 parallel. You can using the formula R total equal R1 times R2 divide R1 plus R2. Okay. This is the formula for we call a current divider law. Okay. That means you get a total current here. They go up to this point, I1 go this way, I2 go the other way. If you want to calculate the I1, you can using formula. I1 equal I total times R2 divide R1 plus R2. Or if you want to calculate I2, then there will be a I total times R1 divide R1 plus R2. Okay, this is the same example here. So basically for this example, they given parallel to resistor R1, R2. They want to calculate the total resistance. You already know R1 times R2 divide R1 plus R2. Okay. If you want to calculate the I total, that means the current I here, take the E power supply divide R total. Okay. If you calculate the power, okay, of the power supply to the circuitry, you're using the formula V times I. That means E times I total. Okay. Then if you want to calculate the I1 or I2, you're using the formula, the current divider law. Okay. Then you can calculate the power for R1 using E squared divide R1 or E squared divide R2. Okay. I already given you the answer. You try to do it by yourself. Okay. Now, on this thing here, really what you need to know when you start working on the lab, when you want to measure the voltage, that's what we call a DMF or meter. They can be measured the voltage, they can be measured the current, and they also measure the resistance. Okay, so basically the voltage, they can measure the DC voltage or AC voltage, depending on you set to this one, you measure DC. On the other one, you measure AC. And if you want to measure the current, and that will be a DC current, AC current, you measure the resistor. Okay. Only thing I make sure you understand, when you measure the voltage, you connect positive of the voltage to C, negative to the ground. Okay. Or to different point. But when you measure the current, then the positive on the current connect to point A, and the negative will be connected to point B. What that mean? That means you break the wire here, okay? And positive connect to A and negative connect to B. Let the current flow through the meter and go back to power supply. Normally, you will be working on measure the voltage, not measure the current in the company. The thing is why? In the company, you get the circuit board. If you want to measure current, you have to break the board. They not allow you to do it. Okay? So if they want the current, they can measure the voltage. And using I equal V divided to R, they can get the current. And this is the one normally a meter we're using in the lab volt system. They're the same thing. Okay? That you can see, recognize that is the voltage AC, voltage DC. Okay? This is the resistor measure. Okay? This is the measure the current. Okay? AC, DC current. Okay? And also, when you connect, you measure the voltage, you connect positive here, negative here. However, when you measure the current, then connect positive at this point, negative the same thing. Okay? So, you're reading here, you can see, if you're using a DMM to measure DC and AC, okay? On the AC, the voltage will be get the VRMS. You cannot see V peak or V peak to peak with the meter. Same thing, DC, AC have to be IRMS, okay? And measure the resistance, continuing, okay, option. That means depend on how much you pay for your meter. You can measure capacitance, measure the diode, measure the frequency. Okay? That's it for now. Okay? I have to stop it. And make sure you get the time to reading the handout. We downloaded today, okay, for rectification. That's what we will start it tomorrow. Okay, anyway, any question? Just let me know, either I go too fast or either you get to understand what I'm talking. Just bring it up. So I can get, yeah, go ahead.
I'm having a hard time understanding the math, figuring out the like it's a lot of different variations of coming up with the formula, and I'm a little confused on how the answer comes out. I hate to go back all the way to the beginning, but one of them that I found that I couldn't calculate on my own was an example on page 6, letter C. I was able to do the other ones except that one. And then after that, I kind of just went over the measurements, what each symbol means, and, you know, so it's kind of hard to like follow the rest until I kind of get the understanding of all of them. So
Okay, now you're talking about which one?
the example number 3. I mean, letter C.
Example.
Do you remember what slide number it was?
I'm seeing number 6.
Slide number 6, okay.
Okay. Now, which one?
Letter C.
Oh, C. Okay, let's see, 141. That power minus 2. Okay, let's see, 141. You turn it into the power of 10. So that will be 1.41 times 10 to the power of 2. Is it right?
What I did was when I multiply, because the power of 2 means 141 times 141, or am I understanding that incorrectly, that it equals 0.503?
Okay, 141 times 141, right?
Yeah, is that how I calculate it? That's my,
Yeah, let's see, I see what I get. 1.41 times 1.41 equal to 0.002. Okay, then the power minus 2, correct?
okay,
Okay, now either way you want. Okay, if you say one, let's see, 2.002 at minus 2, right? Then you can do this way. 1 divide 2.02 power 2. Okay, now I want to square this one. Okay, so basically 1 divide 4.008. Okay, so the answer will be 0.249.
Mr. Pham, I don't follow where you got 2.002 from.
me neither. That's where I'm lost.
Can I
One-
help? Can I help
No.
interject
Yeah.
just really quick?
Now 141. If they want to put number 2 here, that means same thing, 141 times 10 power of 2, same thing, right?
Yes,
Either way. Okay, but this is basically from the textbook. They really screw up. Okay, now I do my way. Okay, 141 power minus 2, correct?
yes,
Same thing. 141 power
square,
2, right?
yes,
Okay, so you take a square root, you get the square of 141. Okay, 141 square.
19881.
Let's see, 141 square. 19881, right?
Yeah, that's what I'm getting.
19881, 1 over. So you take a 1 divide to that number.
5.03 times.
Yeah, you get 5.03
Times 10.
ah, okay, power minus 5, right?
Yes,
You get that?
yes,
That's correct.
yes.
Ignore about what they said here. The thing is, I thought it easy, so that's why I'm not go through it.
Okay, I understand now. Thank you.
Okay, yeah, sorry. You know, the textbook sometimes really confusing. Even I'm teaching, confusing myself. Okay. Okay, so this time Mr. Sam, go ahead and run the quiz.
Yes, sir. Okay, so make sure that go ahead, stop sharing first and then.
Yeah,
start.
just a minute.
Okay, yes, sir. Okay, so share screen. Okay, so make sure that you go to the website and make sure you go to the handout. And you want to download this report right here. It's DC Quiz 01 Fall 2021. Okay, go ahead and download that so you can be able to. This is the answer sheet that you can put your answer on, and make sure you upload it to the website later on. Okay. Any question? Okay, so now I'm gonna run the test.
Can you repeat that?
Okay, so I'm gonna be running the test. So this is like the answer sheet. So you click on that to download that and click it to open it up. And click it will be on the bottom here. It would show up. Okay, so this is what it looks like. Let me go ahead and sort of get this one to be bigger. So this is the answer sheet that it's going to be the multiple choice is going to be 1 to 13. And then this one you're going to type in the value. Okay, so if it's 15 ohm, you type in 15 and make sure you click on enable editing on top. Okay, so now you can edit and make sure you put your name on here. So my name. And then come here. Okay, so I'm gonna run the test, and you want to do just type your answer here. So the answer is C. You go to number 1. You can type in lowercase or capital case. Doesn't matter which one it is. I will be looking through it later. Okay, type in the letter C and press enter. So now you're waiting for the next question 3, 2, 3, 4, and so on. So make sure you answer all of them as much as possible if you know how to do it. If you want to skip and leave blanks, that's fine too, if you're not sure. Okay. And here you type in the answer. If it's like say 15 ohm, you type in 15 ohms and then press enter. Okay. And then make sure you save this file onto your computer so you can upload it to the website. Okay. So right here, enter your name and ready to upload onto the website later on. Okay. Okay. You have any question, Alexander?
No, it's good. Thank you.
Okay, all right. So, okay, now I'm gonna run the test. Let me go ahead and minimize that out the way, get all this out the way. Okay, so here we go. Okay, good luck, everyone. Okay, so that's the first one. So, can everyone see?
Yes.
Yes, yes, okay, thank you.
Sorry, Sam, are we just supposed to be taking a picture of this, or are we supposed to actually be doing this while we're
You
waiting?
want to do this as we go through. Like I said, later on, if you need some extra time to do it, you can watch the video. Okay, watch the video that Mr. Pham will be uploading this onto the website, and you can use your notes that from the handout that you got from the class to help you out. Okay, and this one is due by noon by tomorrow noon time. But if you need to take pictures to help yourself, so go ahead and feel free to take a picture. If not, like I said, you will have plenty of time to look at the video. Okay, so that's pretty much it. So make sure you go through it, do it the best as you can, and make sure you upload to the website. It's due by 12 noon tomorrow. And so if you want to turn in right now, that's fine. You go ahead and turn it in. If not, you can turn in a little bit later. Okay.
Sam, can you send me the answers before 12 noon tomorrow?
No, sir. Have to wait until Monday. Okay, so any other question?
Hey, could you show us the first three questions again, please, real quick?
Okay, so yeah, like I said, let me go ahead and run through that. Share once more. The first three questions. Okay. Can you see that? Can you see it, Michael?
No, I cannot.
Okay, let me go ahead and click on share. Let me see, share screen. Share screen. Okay, can you see it now?
There it is. Yes, thank you.
Okay, you're welcome.
I have another question.
Yes.
So, you know how on Wednesday, Thursday, and Friday there's no class? Is that because the class is in person?
That's Mr. Pham would answer you that question.
Mr. Pham?
Yeah, what?
So you know how the class is on Wednesday, Thursday through Friday? Well, what I mean is, hold on, let's see here. So hold on, I'm gonna share screen.
Go ahead.
Hey, Jan, it says Zoom's Monday, Tuesday, and then labs Wednesday, Thursday, Friday. Lab means in person.
Oh, I didn't notice that. So, but do I have to turn in my vaccination documentation? You know, so I can go into the lab thing?
Yes, you do.
Okay, thanks. Thank you.
Okay.
Stopping share. Thank you. Thank you for that information.
All right, let me see. So we're going to minimize this one.
Bye, Mr. Samyi.
Bye-bye. Okay, so we're going to be. Stop. Let's see. Okay. Okay, Mr. Pham, I did collect those names for student that for the lab schedule. Do you want me to show you and whether you want me to send it over to you on email or not?
See, I don't know why I couldn't see my Zoom
Okay.
again.
Let me say. Okay. Go ahead and stop the recording.
I want to do it, but I cannot do anything.
Oh.
That's what I don't understand.
You're gonna have to log off, Mr. Pham.
Even I want to log off, I still cannot.
You're gonna have to pull the plug then.
Look like
Thank you, Mr. Pham.
Pull the plug, Kumi.
I will. Let's see if he needs help.
I don't know. I cannot do anything.
Okay. Do you want me to go ahead and show you the list I have so that way whether you want me to send over to your email or not afterward?
Yeah, you can send to Mr. Pham and me.
Okay, let me go ahead and show you first whether you want it or not. So this is what I have. It has a list of all the names of the student and the time schedule that they want. Okay. Can you see it, Mr. Pham?
I didn't see anything on my screen.
Oh, okay. Well, if not, then I'm going to email you the information so you can have the same information then.
Yeah, I can see the picture,
Okay.
but basically,
The last one?
You need a new computer, Mr. Pham.
it cannot do anything.
No.
Now they happen again, it did not display my Zoom.
Yes.
That's what I don't understand why that happened.
Mm.
You had to buy a new computer from Sam.
Okay. Thank you.
For the one.
Yeah, thank you, Miguel. Thank you for putting your time
Okay,
schedule
so
for me. Okay, I
talk-
will
We'll
update it.
talk to you guys tomorrow.
Thank
Okay.
you.
Thank
you.
Good
Thank
night.
you.
Thank you.
Right.
Thank you. Good night.
Good night, everyone.
Guess I'll have to buy a computer from Sam.